Hey, I hope you all are staying warm today, and I just wanted to take a minute to go through what we would have discussed in class. And like I said on Friday, please list the questions you have. I expect there to be some. Can be a confusing concept, and it can be, especially it's a little bit more confusing depending on how much of a background you have in some of these areas of science. But even if you don't have a super strong background, I think this is actually a structure or an approach that can be really helpful, especially if you don't feel like you have a super strong background in this sort of thing. And so this is what we call the Earth Systems approach, or you'll hear Earth System Science. That's actually the ESS that you've seen in the beginning of some of the standards numbers. That's what the ESS stands for, Earth System Science. And so the idea is that there are 4 spheres or areas or systems on the Earth, and that they are constantly interacting. And when an event, volcano erupting, hurricane, tornado, new disease, new species, any of this, when an event happens, it interacts and is impacted with each of those spheres. And so the idea with this is not to just come up with some big confusing idea to make this more difficult, but it actually gives us really specific places of looking or specific directions or things to think about when we're exploring a topic, especially in Earth System Science, but it affects life science quite a bit as well. So the 4, what I'll call spheres or systems, we have the atmosphere, which is the gases around the planet. So I know we think of atmosphere as just like up high, but it's the gases. It's the air, the carbon dioxide, the nitrogen, and all the things that are mixed into it. Often weather, the way we think of it, is a characteristic of the atmosphere. So the fact that right now it is insanely cold, when we say it's really cold, what we really mean is that the atmosphere is at a very low temperature. The atmosphere has very little heat energy in it right here. So the atmosphere is the gases that surround the planet, and the characteristics of those are what we call weather. So temperature, wind, things like that are characteristics of the atmosphere. Apologies. The biosphere are the living things. So that's plants, animals, but also algae, bacteria, fungus, viruses count in the biosphere. Anything affecting living things. And so a lot of times we tend, and especially students tend to think of this as just plants and animals, and plants and animals definitely count, but it also goes a lot deeper than that. So, all the way down to algae and bacteria, and how those might be impacted by climate change, a flood, whatever it is, pollution. So the biosphere are all the living things. The hydrosphere is the Earth's water. So it's obviously oceans, lakes, streams, but it also includes groundwater. It also includes ice in the sense of glaciers, ice caps, things like that. And water vapor. And so a couple things. One is you might see a version of the Earth system spheres that separates ice into its own group. So you might see that, and they call that the cryosphere. There is some benefit to that, but I think, especially at the elementary level, it makes sense to keep that all as a hydrosphere. That is all water, and it does change in between forms. So glaciers and ice caps can very easily become streams and rising ocean levels and things like that. Water vapor is the one that gets a little bit tricky because it is hydrosphere, it is part of the planet's water, but it's often up in the sky, it's up in the air, mixed in the atmosphere. So it said that weather is a characteristic of the atmosphere. That's true for temperature and wind, but when we get to things like precipitation, the fact that it snowed, for it to snow was an interaction of the hydrosphere of the water vapor in the air, how much was there, with the atmosphere, what the temperature of that air was. So water vapor is one that can be a little bit difficult to kind of figure out which group it fits in, but it is part of the hydrosphere, it's water. And then finally the geosphere, or I might use the term lithosphere. They're basically interchangeable, and unfortunately I haven't quite gotten out of the habit of just using one and not the other. But the geosphere refers to the Earth's crust and mantle, really. It lists the inner core and outer core, and with earthquakes that makes a difference, but for the most part, events that we deal with on Earth are really interactions with the crust and the very upper part of the mantle. On the surface of the Earth, what that means is that's the rocks and soil, and so when we think of a geosphere impact, it could be something that's impacting the soil. And the reason we use this is that there are a lot of events that have really complex interactions, and it's easy to miss, and it's easy for students to miss those until you give them a very specific direction to look. And so one of the examples here, and I was trying to choose an example that I didn't think was one that any of you would use in an assignment. Oops. This is the pika. A pika is a relative, really its only living relatives are rabbits and hares. This is a high elevation creature. They're small, in between like hamster and guinea pig size. If you've been up high in the mountains, you'll see them dart running around like you might have thought it was a chipmunk or a mouse or something. And they have this real like squeaking sound they kind of make as they dart around. They also tend to not get along with each other super well, so if you're at an elevation where there are a handful of them, you'll hear them like squeaking at each other and getting all worked up. And what they are doing typically while they're squeaking at each other and getting mad is that they are gathering as much plant material. Basically, they're building a hay pile to get through the winter. Pika are a species that are really at risk right now. One of their key characteristics is they really cannot survive warm temperatures at all. And so temperatures over about 70 degrees for much of a period of time will kill them. And in fact, if you were to hold one, your body heat would be enough that it probably would not make it very long. So, if on a summer hike you saw one darting in and out of the rocks and grabbed it and thought, oh, I'm going to hold it and, cuddle it, they're super cute. That, one, it's a wild animal, and that's not a great habit for any wild animals. But it would kill it, right? It's so sensitive to heat. So that sensitivity to heat would actually be an interaction between the biosphere, so this is a living thing, and the atmosphere. So it depends on a particular temperature, or more fairly, it depends on not getting above a particular temperature. Now, that need to not be above a certain temperature is why they live up very high in the mountains. So they typically live in general, we would have said in the Colorado Front Range area, we would have said above 11,000 feet, something like that. So they're above tree line. And in winter, they actually use the snow as an insulator, and they are scurrying underneath the snow. They stockpile a bunch of plant material during the summer, so they're eating through that, and that's how they survive the winter. Then in the summer, by being up very high in elevation, it doesn't typically get very warm, and they use the rocks to hide if it does start to warm up. So the rocky nature of the landscape is what lets them manage their temperature. So that's an interaction with the geosphere. Right? So this creature, part of its survival depends on the geosphere being in a rocky environment. If it were living at 12,000 feet in a non-rocky place, like it couldn't live on the runway of an airport in Nepal that maybe it's high enough elevation, but there's nowhere for it to hide when it does warm up a little bit. Now, along with that, they can't get too warm, but they do need some protection in winter. And so part of what they use the snow for is protection in winter, because snow is actually a pretty good insulator. And so one of their interactions with the hydrosphere in the form of snow is that they use it for protection from the harshest winter weather. So up on the alpine tundra, which is the habitat type that is above tree line, so up on the alpine tundra, there can be some horrendous winter storms. And so what they do is hide in the snow as kind of an insulator, because if you're in the snow, it's going to be 32, 33, 34 degrees, right? That's it. It protects you from the rest. Where just up in the air, as we all very much well know today, it can be much colder than that. So they depend on an amount of snowpack. So that's an interaction with the hydrosphere. Now, what is happening with climate change is that the winters are getting less harsh. So we've had several winters that have been less snow up high in the mountains. When there's less snow, they have less protection. It melts off a little faster, which can expose them to heat for a longer portion of the year. And if it melts off faster, it leaves them very vulnerable to an early summer, really late spring storm. So if things melt off, areas that maybe have the snow's melted by mid-May, they're really vulnerable if there's suddenly a big snowstorm, blizzard, super cold weather in late May. And that happens a lot. Now, the other piece here of, okay, well, they can't handle temperatures. They can't handle warm temperatures, so we've seen gradually warmer summers. And so the big catch for them is they live on mountains. They can't move. So they are essentially island animals because they live up high in an area where they cannot just move to a colder spot. And so we've seen over the last 10, 20 years, there's been losing populations at lower elevations, and it's just kind of creeping up and up. And eventually they're going to run out of space. Their habitat, their available habitat is shrinking, moving up higher in elevation, and eventually you just run out of possible elevation. So the idea of kind of going back to the Earth systems, why we use those is it gives students very particular places to look or very particular questions to ask. So instead of just saying, hey, what's up with pikas, where a student might do some research or figuring out and be like, it seems like there's not as many of them, which is true. But this gives them some very specific questions, and ones that with some practice they can ask on their own. So they might be like, okay, well, how is the atmosphere affecting them? Okay, well, atmosphere is the gases. I don't think there's a ratio of gases that's affecting them. It's also the temperature of the air. Oh, well, that affects them. Wind, well, that probably could with weather too. right? And so there's a couple interactions that they can start to recognize, and it doesn't take a whole lot of like giant background research. So the way I would approach teaching this is it usually helps to role model going through, taking an event and talking in class about how it could affect each of these. Sometimes, and especially at the younger grades, it can be, how do you think it could affect them? As they get a little bit older, I've made students say, how would it affect each of them? And you have to give a source for each one. So if you're telling me that tornadoes are bad for trees, provide evidence, and so they'll find a picture from after a tornado. They'll find a newspaper article or whatever. But at the younger age, saying, what do you think could be interactions or ways this would impact? That works. So working through examples as a class, this is also something that you can split students up and have them work in groups. So you can have a group working on how would a volcano affect the hydrosphere? How would a volcano affect the atmosphere? And they can report back together. Sometimes with that, I've taken the giant sheets of butcher paper, the big color paper that every school has in the teacher's workroom, and hung one of those up and sectioned it off so each group would go and put what they found, about how volcanoes impact the geosphere, or how the geosphere impacts volcanoes, right? It goes both ways. These are two-direction arrows. They all put it on the giant paper, and then we can all see it as a group. It's something that eventually they can do individually. But the idea in using it is to give them very specific directions to look. Like I said, I expect this to probably be confusing. List questions, if you want to send them ahead of before Wednesday to me, awesome. We'll talk about them Wednesday. If you bring them with you, that's fine. Also, if you're working on your read aloud activity today, tomorrow, feel free to send questions as you get stuck. You can ask about it Wednesday, but I know that's a little bit shorter notice than you might want. Stay warm, stay safe, and I will see you all Wednesday.